Hey students, welcome back. Today we're going to learn about doing some chemistry modeling and some chemistry math, thinking like a chemist. So my thinking like a chemist guy, he's always here with me, good old Beethoven, Beethoven as I like to call him. All right, so we're going to go ahead and get started today. We're going to talk about different types of things, shape sorters, okay? Things like that help us understand our world. We try things through trial and error. So when you're a little kid, you might have played with some toys and it was okay to do things with trial and error, right? It was okay with that. So sometimes one method doesn't work. You have to try it with another method. So that's what we're going to be doing today is learning about different types of problem solving skills that will help you in many areas of your life, particularly help you in your math class. It'll help you if you're breaking down a project that you have to do, just a personal project at home, organizing your room, or maybe you got a woodworking project or something, a project you want to create something, an art project. These types of skills translate beyond chemistry, beyond school. Okay, so what is a general solving problem? And affecting problem solving strategy will always begins with developing a plan. You got to have a plan and then implementing that plan. So I call it plan the work, then work the plan. Plan the work, then work the plan. It could be as simple as I need to get up in the morning. I need to get out to get to school on time. What do I got to do? I got to develop a plan to do that, to take out some of the stress of my morning. What can I do to make my mornings less stressful so that I can get to school on time with less stress, right? To be simple as setting an alarm clock, going to bed earlier, setting out your clothes, packing your bag, making sure everything's charged up and ready to go, making sure you know where the keys are at if you drive to school. So develop a plan and then work that plan. Do what your plan says, okay? So simple shopping involves problem solving skills. You go shopping, you may need to understand how much you need of something or how am I going to do that. So for instance, how many gallons of milk do I need? How many rolls of toilet paper do I need? Do I need one or two cans of green beans for the recipe I'm about to make? Okay, so there are three basic problem solving strategies. I'll addendum to make them a little bit more Mr. Rosy here. Okay, and they are called analyze, calculate, and evaluate. Okay, I'm just going to put those out here for you. Analyze, calculate, and evaluate. Analyze Analyze means you're going to assess the problem. What you got? That's the thing when I teach you this one. What you got? What did they give you in the problem? What numbers did they give you? Anything that's associated with numbers, that's what they gave you. Then the next thing is what you need. What do they need? Calculate. What do you actually need? What are they asking for? What is the problem? And then finally, evaluate. Get it done. Does this make sense, my answer? So, for instance, if you're at the store like this person right here, okay, you're at the store right here, what to analyze. I have a recipe that I need to, and I want to make seven. I want to make green bean casserole for seven people. Well, I need to analyze. Well, how many green beans am I going to need? What does my recipe call for? Okay, that's going to translate to how many cans or ounces or volume or mass or whatever it might be of green beans I'm going to need to make enough green bean casserole for seven people. Okay, so then you're going to analyze that, you're going to calculate it, and then you're going to evaluate. So as you look at your cart, do I have enough green beans here? Okay, I have enough green beans. Let's go ahead and let's go over and get the next ingredients, whatever it's cream and mushroom soup and dried onions. I forget what the other ingredients for that are. But the idea is you do this in everyday life, okay? So we're going to talk about the word problem here. So when you analyze a word problem, you must determine where you're starting from, identifying what is known. And this is why I call what you got. What is known, what you got. Identify where you're going. What is the unknown? What do you need? What are they asking for? After that, you've identified what you know, what you got, and what you need, the unknown, make a plan for getting there. And then you calculate that. You calculate it, make an effective plan, use your calculator, make sure you got your units correct. We're going to talk about that a lot this year. Then evaluate. Does your answer make sense? At the store, if you buy 30 cans of green beans, your calculation, you somehow calculate it, you need 30 cans of green beans for seven people. Does that make sense? I hope you think, no, it does not make sense. Does one can of green beans feed seven people? Probably not, right? So you need to evaluate to make sure your answer makes sense in things like significant figures, which we'll talk about as well. Okay, so here's a problem here. We're going to estimate you're visiting the city of Indianapolis for the first time. Because it's a nice day, you decided to walk from the state capitol to another place called Murat Central, or Murat Center. I think that's how you pronounce it, for an afternoon performance. Back in the day when we could walk anywhere we want, right? And didn't worry about social distancing. According to the map, the shortest route is from the theater, from the Capitol is to theater is 8 blocks. How many minutes will the trip take if you to walk 1 mile in 20 minutes? Okay, so here's a map. Here's our map right here, and we have a theater, and we're going to walk there. So here's how we're going to do. What is our knowns? The map is not as important as this right here. What are our knowns? We know we need to travel a distance of 8 blocks. That's how we know from one place to the other is 8 blocks. We know that our speed, or our walking speed, is 1 mile for every 20 minutes, or it takes us 20 minutes to walk 1 mile. It's a nice leisurely walking pace. Okay. What else do we know? We know that 1 mile in this city is 10 blocks. So how long is that going to take in minutes? How long is it going to take us to walk 8 blocks, walking 20 minutes per mile, and that 1 mile is 10 of those blocks. So the problem is an example of what's typically called a conversion problem. We're going to convert that. So we're going to divide the distance in blocks by the number that are in a mile. So this is how we're going to do that. So we have blocks, and we're going to see how many miles is 8 blocks. So what we're going to do is, we know that our conversion factor right here is called 1 mile per 1 block. So we know we're walking 8 blocks. So we write that first. So this is what we got. And what we need right here is, how many miles is that? Okay, how many miles is that? So 8 blocks times 1 mile divided by 10 blocks per mile. That means that 8 blocks is 0.8 of a mile. Okay, 0.8 mile, right? So that we know that, and that's how long our distance is. We know we're going to walk from one place to the other is 0.8 miles. How long will it take to be there? Where our conversion rate is that it takes us 20 minutes to walk 1 mile. So then we write down what we got. We know that our distance is 0.8 mile. We write down what we need up here. Always write down what we need in the top. 20 minutes. So we do 0.8 times our walking rate of 20 minutes per mile. Our units cancel out. So 0.8 times 20 divided by 1 is 16 minutes. So we know that it's going to take us 16 minutes to go from where we're at the Capitol to go to the theater. So we need to account for that when we want to make sure we get to the performance on time. So that's an example of a problem. Okay. That is an example of a problem that we'll do. Okay. All right, so we'll skip through here. Let's try another type of problem. They're called conceptual problems. Now, conceptual problems are something that are helpful to us. And there's 2 steps to those conceptual problems. We analyze them, and then we solve them. Okay, we analyze them, and then we solve them. So, for instance, Manny has to run 6 errands between 10 and 5 on Saturday. He must go get a haircut, wash his car, buy stamps, rent a video, and get some groceries. Assuming that each errand will take 30 minutes and he can only do 1 errand per hour, Manny will stop for a lunch break between 12 and 1. Use the information to draw a figure to figure out how many out a way for Manny to accomplish all 6 tasks. So you've done this. You've had to run errands with your parents, and you go from here to there to there. What's the most efficient path? Right? Or if you're walking around the campus of your school, I need to go to the science room, then I need to go to the lunch room, and then I need to go to my car because I forgot my lunch in my car, and I need to come back. I have to stop by the office to return my hall pass. You have to do all of those in order. You're thinking about a plan. You're analyzing it just like ours. So here it is right here. Here's a conceptual problem. He's going to drop off a video. He's going to run to the post office and then to the barber shop, and then to the library, into the grocery, and then to the car wash. So based on all of these problems here, this is when they're open, 10 to 6 for one store, 8 to 11 for another, likewise for these other ones. You have to analyze your distance on where you're going to go. So you're going to go to the library, then walk to the grocery store, then go to the video store based on the hours that they're open and the distance. So the reason we do this is called a concept problem. We're not doing any math, but we're doing concept. We're doing more of an order based on the convenience to get there, and also the convenience how long it takes us to travel from one place to the other. Okay, so we're gonna travel those. So what if Marion had 7 errands instead of 6? What do you need to do to adjust the extra errand? So it only has a certain amount of time. You may have to incorporate some efficiencies. So what I'm trying to show you here is just some understandings of how you approach problems. Now, this is a kind of a quick and dirty lesson to you, but we'll talk more about this in class of how we approach problems, and that word problems are not the end of the world, that you can do this, and I believe in you. So I'll talk to you soon. Thanks a lot for listening. Bye-bye.